16 hours of work compressed into 1 hour, a 1,600% productivity boost. That's not a fantasy. That's what happened to a software developer who used AI to tackle what should have been a 2-day project. Research, prototyping, UI development, done in 60 minutes. But here's the twist nobody saw coming. It was, in his words, cognitively unworkable, like running a marathon at a sprint. Welcome to the paradox of superhuman productivity. I'm Will, and you're listening to Mindcast, where we dig into the ideas reshaping how we work and think. Today, we're diving deep into groundbreaking research called the Centaur's Dividend, a study that reveals both the extraordinary promise and hidden burden of AI in the workplace. We're talking about productivity gains so dramatic they could fundamentally change what a work week looks like, but also cognitive challenges so intense they're creating entirely new forms of burnout. Here's what you'll walk away with today. First, you'll understand why AI doesn't boost everyone's productivity equally, and how to identify where it works and where it doesn't. Second, you'll discover why working 16 times faster might actually break your brain, and what that means for the future of human work. And third, you'll learn about a revolutionary approach that could give us both superhuman productivity and a 4-day work week. Because this isn't just about software developers. This is about all of us learning to dance with artificial intelligence. And the research suggests we're stepping on each other's toes. Before we dive deeper, let's establish the scope of this research. The Centaur's Dividend isn't based on a small sample or anecdotal evidence. We're talking about analysis from major tech companies, academic institutions, and independent research groups across 3 continents. The data spans nearly 100,000 developers, encompasses over 50 different AI tools, and covers projects ranging from simple scripts to enterprise-scale applications. What makes this research particularly compelling is its longitudinal approach, tracking the same developers over months and years to understand not just immediate productivity impacts, but long-term sustainability and skill development. Let's start with that mind-blowing 16x productivity gain. How is that even possible? The key lies in understanding what researchers call greenfield versus brownfield development. Think of greenfield as building a house on an empty lot. You have complete creative freedom. Brownfield? That's renovating a century-old mansion with weird plumbing, asbestos, and a foundation that's settling in mysterious ways. The developer who achieved that 16x gain was working on a greenfield project, building something entirely new. The AI had no legacy constraints, no mysterious, undocumented code to navigate, no complex dependencies. Its entire context window could encompass the whole problem. But here's where it gets interesting. Stanford researchers analyzed data from nearly 100,000 developers over 3 years. The average productivity boost? A much more modest 15 to 20%. Why such a massive gap between the 1,600% peak and the 20% average? The answer reveals something profound about how AI actually works. It's not uniformly good at everything. It's spectacularly good at specific types of work and surprisingly bad at others. Here's the breakdown. Greenfield projects with low complexity, AI delivers 30 to 40% productivity gains. That 16 times gain was a peak outlier in this high-performance category. But brownfield projects, working with complex existing systems, can actually slow experienced developers down by up to 19%. Think about this for a moment. The same technology that can make someone 16 times faster can also make someone else nearly 20% slower. The difference? Context. A 2025 study found that experienced developers working on their own familiar but complex code bases were slower with AI than without it. Why? The AI, lacking deep understanding of the legacy system, behaved like an inexperienced team member, making suggestions that missed crucial context and proposing changes in all the wrong places. Let me give you some concrete examples to illustrate this context dependency. At a major financial services company, developers used AI to build a new fraud detection microservice from scratch, a greenfield project. Result? They delivered in 3 weeks what historically took 3 months, with better test coverage and documentation than usual. Meanwhile, the same team tried to use AI to optimize their legacy trading system, a brownfield project with 15 years of accumulated complexity, undocumented business rules, and intricate database dependencies. The AI suggestions were not just unhelpful, they were dangerous, proposing changes that could have introduced subtle bugs in financial calculations. The project was abandoned after 2 weeks when they realized they were spending more time explaining context to the AI than they would have spent just doing the work themselves. This brings us to our first major insight. AI isn't magic, it's a context-dependent amplifier. Feed it the right context, like a clean new project, and it's transformative. Ask it to navigate undocumented complexity, and it becomes a hindrance. What does this mean for you? Whether you're managing a team, choosing tools, or planning projects, understanding this context dependency is crucial. AI will accelerate your greenfield work dramatically, but it might slow down your brownfield maintenance. Plan accordingly. Now, let's talk about why that 16x productivity gain felt cognitively unworkable. Researchers called this new collaboration model the Centaur, half human, half AI, theoretically combining the best of both. Like the mythological creature, it promises superhuman performance. And the data backs this up. In freight negotiation, human AI teams achieve 34% better financial outcomes. In chess, human-machine teams outperformed both the best humans and the best computers working alone. But there's a catch, a big one. The human role in these Centaur partnerships isn't getting easier. It's getting intensely more demanding. You're no longer doing the work, you're orchestrating, validating, and directing a partner that works at superhuman speed. Imagine trying to conduct an orchestra where every musician plays at 16 times normal speed. That's essentially what happened to our developer. His role transformed from varied intensity work, some deep thinking, some routine tasks, to 100% high-intensity, high-stakes oversight. The cognitive science behind this phenomenon is fascinating. Researchers at MIT's Computer Science and Artificial Intelligence Laboratory conducted brain imaging studies on developers working with AI assistants. What they found was striking. Areas of the brain associated with working memory and executive control showed significantly higher activation when collaborating with AI compared to working alone. This wasn't just mental effort, it was a specific type of cognitive load called supervisory attention. Think of it like this. When you're driving alone, your attention can shift between the road, the radio, and your thoughts. But when you're teaching someone else to drive, your attention must remain constantly focused on monitoring their actions and being ready to intervene. That's essentially what your brain is doing when working with AI. You're in permanent instructor mode, which is neurologically exhausting. Researchers have a name for this: oversight fatigue. It's worse than regular burnout because you're responsible for outcomes of a process that's moving faster than human cognition can fully track. Here's where the biology kicks in. Human working memory is finite. When AI accelerates the pace of decisions and validations you need to make, it doesn't reduce your cognitive load, it maximizes it. You're processing, validating, and directing this high-speed output while maintaining strategic oversight. The developer described it perfectly. It required much higher focus and concentration than normal work, like running that marathon at a sprint pace. And here's the crucial insight he discovered. He needed regular consolidation breaks, not rest breaks, but time to consolidate what I had achieved, what my next steps would be. These weren't signs of weakness, they were biological necessities. The human brain has a speed limit for understanding and integration. AI can accelerate execution, but it cannot accelerate human comprehension. Those consolidation breaks become a mandatory part of the new workflow. Execute with AI, then consolidate as a human. Execute with AI, then consolidate as a human. This brings us to a profound realization. In the age of AI, the bottleneck isn't technological, it's cognitive. The question isn't how fast can the AI work, It's how fast can humans effectively oversee AI work? What does this mean for organizations? The old productivity metrics are obsolete. You can't measure success by hours worked or tasks completed. The new metric is cognitive sustainability. How well can your team maintain high-quality oversight over extended periods?
This brings us to the most strategic insight from the research: what to do with all that saved time. Most organizations make a crucial mistake when they see productivity gains. They either demand 16 times more output, which leads to burnout, or they pocket the savings without reinvestment. Both approaches miss the revolutionary opportunity. The research proposes something different: the quality-first reinvestment model. Instead of doing 16 times more tasks, you take that time dividend and reinvest it into the things that typically get neglected: comprehensive testing, detailed documentation, and robust system design. Why does this matter? Remember that brownfield problem where AI actually slows down experienced developers? That happens because AI lacks context about complex, undocumented systems. But what if those systems weren't undocumented? What if they came with AI-readable specifications and comprehensive test suites?
This creates what researchers call the quality flywheel. First, AI accelerates your greenfield development, creating a time dividend. Second, you reinvest that time into high-leverage activities, creating better specifications and comprehensive testing. Third, AI-powered tools automate the execution of these human-designed quality measures. Fourth, the resulting well-documented, well-tested product reduces technical debt, making future work less complex and more accessible to AI. In other words, today's greenfield productivity gains fund tomorrow's brownfield efficiency. But there's more. The research reveals this approach aligns perfectly with developer psychology. When given AI-generated time savings, developers naturally want to reinvest into higher quality work, learning opportunities, and solving more complex problems. The quality-first model simply formalizes this instinct. There's even a methodology emerging to operationalize this: spec-driven development. Instead of writing code and documenting it later, you co-create the documentation with AI first. The specification becomes the source of truth, not the code.
Real companies are already implementing variations of this quality-first model with remarkable results. Spotify's engineering teams pioneered what they call AI-augmented documentation, where every new feature begins with an AI-human collaboration to create comprehensive specifications before any code is written. They report a 40% reduction in bugs making it to production and a 25% decrease in the time needed for new team members to become productive on existing projects. Similarly, Shopify introduced quality time banking. When AI tools save developers time on routine tasks, 30% of that saved time must be invested in improving code quality or developer experience. The remaining 70% goes toward new feature development. After 18 months, they found that their AI tools became progressively more effective because they were working with better documented, better tested code bases. It's a virtuous cycle in action.
Think about this paradigm shift. Documentation stops being an afterthought and becomes the primary input to the development process. AI models can generate documentation with up to 99.94% accuracy, meaning this approach is both practical and powerful. This transformation solves multiple problems simultaneously. It prevents cognitive overload by forcing planning before execution. It provides AI with the context it needs to be effective on complex projects. And it creates sustainable productivity gains rather than unsustainable speed increases. What does this mean for your work? Whether you're in software development or any knowledge work, the principle applies. When AI makes you faster, don't just do more, do better. Reinvest the time dividend into the strategic, creative, and quality-oriented work that typically gets sacrificed for deadlines.
So, how do you actually apply this research to your work and life? Let me give you 3 concrete takeaways. First, master the context map. Understand where AI excels and where it struggles. AI is transformative for well-defined, independent projects, your greenfield work, but it can hinder complex, context-heavy tasks involving legacy systems or undocumented processes. Before deploying AI tools, ask yourself, is this greenfield or brownfield? Allocate accordingly.
Second, embrace burst and rest cycles. The traditional 9-to-5 steady-state work model is obsolete in the AI era. Your new operating system should be cyclical. Intense AI-assisted execution phases followed by mandatory consolidation periods. These aren't breaks. They're when you maintain your strategic oversight, plan next steps, and prevent cognitive overload. Think of it as interval.
Third, adopt quality-first reinvestment. When AI makes you 20% more productive, don't just take on 20% more work. Invest 10% of that gain back into quality infrastructure, better documentation, more thorough testing, clearer specifications. Give the remaining 10% back to yourself as more sustainable working conditions. This creates a virtuous cycle. Better quality today enables greater AI effectiveness tomorrow. These aren't just individual strategies. They represent a fundamental shift in how we think about productivity, work sustainability, and human-AI collaboration.
For managers and team leaders, this research has profound implications for how you structure work and measure success. The traditional approach of measuring productivity by lines of code written or tickets closed becomes not just obsolete, but counterproductive. Instead, successful AI-augmented teams are adopting what researchers call value-based velocity, measuring the long-term value created rather than short-term output. This means tracking metrics like reduction in technical debt, improvement in system maintainability, and increase in team learning and capability development. Teams that embrace this approach report higher job satisfaction, lower turnover, and, counterintuitively, faster delivery of complex projects over time. The key insight for managers is this: your role shifts from maximizing individual productivity to optimizing the entire human-AI ecosystem for sustainable performance. This means providing cognitive recovery time, investing in AI literacy training, and creating organizational structures that reward quality-focused reinvestment over pure speed. While this research focused on software development, the principles extend far beyond coding. In healthcare, radiologists using AI for image analysis report similar patterns: dramatic efficiency gains when reviewing straightforward cases, but cognitive overload when the AI flags complex or ambiguous findings requiring nuanced interpretation. Legal professionals using AI for contract review experience the same dynamic. Simple contracts get processed incredibly quickly, but complex multi-party agreements with unusual clauses require intense oversight of AI suggestions. The pattern holds across knowledge work. AI excels at well-defined tasks, but struggles with context-heavy, ambiguous situations. What's universal is the need for what one researcher calls cognitive pacing, structuring AI-augmented work in sustainable rhythms rather than pushing for maximum acceleration. Whether you're a designer, analyst, researcher, or consultant, the same principle applies. Use AI to handle the routine so you can focus on the nuanced, but don't try to maintain peak oversight intensity for 8 hours straight. We've covered a lot of ground today, from that extraordinary 16x productivity gain to the cognitive challenges it creates, to a revolutionary approach that could reshape how we work. The central insight from the Centaur's Dividend is this: the productivity gains from AI aren't just about doing more, they're about creating space for what humans do best while letting AI handle what it does best. The research suggests we're standing at a crossroads. We can choose the path of unsustainable acceleration, demanding 16 times more output and burning out our cognitive capacity. Or we can choose the path of thoughtful reinvestment, where AI productivity gains fund both organizational quality and human sustainability. Done right, this isn't just about better software development. It's about a new social contract for the AI age, one where technological gains are shared between organizational advancement and human flourishing. The research even suggests this could enable sustainable 4-day work weeks while maintaining competitive advantage. The question isn't whether AI will change how we work, it's already happening. The question is whether we'll design that change thoughtfully or let it happen to us. Here's what I want you to do. Identify one area in your work that's greenfield, where you could benefit from AI assistance without complex legacy constraints. Experiment there first. Then, take the time you save and invest it in making your more complex work more AI-friendly through better documentation or clearer processes. If this episode changed how you think about AI and productivity, share it with someone who's grappling with these same questions. Subscribe to Mindcast wherever you get your podcasts. We're exploring the ideas reshaping how we work, think, and live. I'm Will. Thanks for listening. And remember, in the age of artificial intelligence, the most human thing you can do is think strategically about how to work sustainably.